Bismillahirrahmanirrahim. Welcome to Being Guru Electrical channel. This is Mujib Raza with you in the interview question answer series. Today we have series number 4. So before going to start the video, if you are new on the channel, so hit the subscribe button and turn on the notification by clicking the bell icon, so you will receive our channel updates timely. Okay, so let's start. Question number 1. Today we have why auto transformer is used in transmission substation. If ever you go to transmission substation, you will find auto transformer. So what's the reason behind using auto transformer in the transmission substation? So auto transformer is voltage regulating device, and in substation voltage is adjusted frequently as per load requirement. As we know that auto transformer is used to change the voltage as per the load requirement. If load is increased, so the voltage reduces, so we can increase the voltage from the transformer. So auto transformer is used for the voltage regulation, and also for the auto transformer we have only one winding inside, which is the primary, and secondary is only the tapings which are taken from the primary winding. So if we compare auto transformer with a two winding transformer, so less copper is required in the auto transformer as we have only one winding. So this save us cost by using auto transformer. Then if auto transformer ratio is less than or equal to 1, then we use auto transformer. This criteria is used for the selection, either to select auto transformer or two winding transformer. So like if you take 11 kV divided by 415 volt transformer, so if you calculate the ratio, it is around 10, which is more than 1. So in that case we take two winding transformer. But if you take 220 by 132 kV transformer, so the ratio is nearly equal to 1. So in that case we take auto transformer. So this is about the auto transformer, why we are taking auto transformer in substation, in the transmission substation. Next, question number 2, we have what is impedance voltage. Impedance voltage we already discussed in the percentage impedance calculation lecture. You can I will give the link here, so you can check if you didn't check. Anyhow, impedance voltage is the voltage at which rated current flows in the secondary of transformer during short circuit test. What we do in the short circuit test, we short the secondary of the winding and we apply voltage at the primary, and as we increase the voltage at the primary, so at one time comes that rated secondary current flows in the secondary winding. So at that voltage at which rated current flows in the secondary, so we call that voltage is the impedance voltage, and this is very important in the calculation of percentage impedance of any given transformer. Percentage impedance is also mentioned on the nameplate of a transformer, but this is cross check at the type test during the short circuit test. This percentage impedance is verified at the laboratory before going to commission and installed. Question number 3, we have why capacitor is used in a single phase motor. Every single phase motor you will find capacitor. So what's the reason behind this capacitor? So single phase induction motor cannot produce a rotating torque. Single phase induction motor cannot produce a rotating torque. That's why we use capacitor to make a second phase. From one phase we make two phases. So starting torque in single phase induction motor is 0. As this starting torque is 0, so we cannot start from single phase, we have to split the single phase into two. So for this splitting we use capacitor. So capacitor is used to develop starting torque by creating a phase shift between the currents. So we create a phase shift, so in that case we have two currents or two phases. So this can be achieved by adding the capacitor in the winding. There are other ways to split the phases, which include split phase or resistance start method, capacitor start, the one we are discussing, permanent split capacitor, capacitor start, capacitor run motor, electronic starter for single phase motor. If you want to make a lecture on this, so give me a comment, so I will make. Anyhow, question number 4, what is meant by temporary and permanent fault in the transmission lines? There are two types of faults in transmission. One is temporary and one is permanent. So let's see. Temporary faults are those faults which are cleared by auto recloser. We have auto recloser device with a circuit breaker. Like in case of any fault, if the circuit breaker is open, so auto recloser close the breaker after 3 minutes or 5 minutes depending on the setting. So 80% of the temporary fault cleared by a first recloser. So the reason of the temporary fault may be lightning strike, maybe bird electrocution, high winds. 80% of the fault in the transmission, overall 80% fault are temporary, and out of this 80% we have 80% which are cleared by first recloser, and then 15% cleared by second recloser, 5% cleared by third recloser. But there are limitations on the auto recloser. On high voltage we are allowed to use only one recloser. In medium voltage you can use only 3 recloser, but low voltage you can use any number of auto recloser. It's depend on you. Permanent fault causes sustained disruption until cleared by protection. Permanent fault, you have to do the maintenance and it causes sustained disruption. The fault will be sustained if you didn't remove the fault. So it is called temporary fault. It may be due to high winds, ice loading, thermal heating, sag, tree growing in lines, automobile striking tower, earthquakes, flooding, crane or heavy machinery hit line. So there are too many permanent fault. So these all fault you have to remove the fault and then close the breaker. Next, question number 5, we have how transmission line works without neutral conductor. You may see the transmission line, we have only 3 wires going, red, yellow, blue, 3 phases, there is no neutral. So what's the reason behind not using neutral conductor in the transmission line? So transmission line is considered balanced 3-phase circuit. Transmission line is balanced. So from the powerhouse, the balance power is transmitted to the substation. Then from the substation, then we give neutral from the transformer. So transmission line don't require separate neutral conductor because it's 3-phase balanced. Neutral is required where one single phase utilization is required for the load. Earth is used as neutral conductor in case of fault. For the transmission line, we have earth, and if any phase come in contact with the earth, so the earth is itself a conductor, so it closes the path, and we have earthing at the source and earthing at the substation, so we can know that our line is shorted with ground. So in that case our ground is acting as a neutral conductor in case of fault. So this is all for today. If you like the video, give it a like, and if you have any comment, put it in the comment section down and share the video with your friends, and see you soon in the next video. Thank you.